Starting off now in Chapter 3, Lesson 1, we're looking at this particular graph, and it's asking us to determine the domain and range and listed in interval notation. So let's, over here on the side, put domain, range, and also I'm going to put there whether it's a function or not. These are the things we went over in the flipped classroom. Now remember, domain are x values, range are y values, and something's a function if the domain element is only used once. And to find the domain then, we take, let's say, this line or this line already, project it down to the x-axis, and what do we see here? Well, it's starting at, and we use a bracket to indicate that is included, at a -4. And then it's going up to a +1, and 1 is included, and that makes it an interval notation. There we have it. Now for the y values, again, we take either of these lines, project it over to the y-axis, and this is starting at 0 and going up to 3. And again, I'm using brackets because these members are included in the set. Now, is it a function? Well, for a function, we do the vertical line test. And as we pass that vertical line over the diagram, the graph, notice that when it reaches this point, there's an infinite number of values there. And then here there are 2. So this is not a function. All right, let's go on. Many of these are multi-steps. So we're showing just one, but we will include as much review as we can on each one. So here, this is the relation, and they want the domain and range. And then also, is this a function? Well, again, domain are the x values. So this is crossing the line right there. So that value, and we use braces for this actually, and that is a -2. Kind of a funny looking 2. Now for the range would be y values. Again, projecting this over to the y-axis, it goes on from, or comes up from -infinity and goes on to +infinity. Now, is this a function? Well, again, if we use the vertical line test, as that vertical line reaches the vertical line of the graph, it's an infinite number of places, so this is not a function. Now, for some reason, the numbers of the examples are coming out, but this would be example 3. And we're asked to find the implied domain of this function. Now, normally we have, for a function, the domain would be all real numbers. But in some cases, there are limitations. If there's a radical sign in there, anything that would make the radicand negative would be excluded from that domain. And if there were a variable in the denominator, anything that would make that variable 0, that value would be excluded as well, since that would not be a real number. It's undefined. So what's the protocol to find this? And the answer is, well, what is the radicand here? And the radicand is x plus 4. Well, this cannot result in it being negative or less than 0. So our values that would make this valid would be greater than or equal to 0. So we just solve now for x, and we get x is greater or equal to -4. So putting that in the interval notation for its domain, it would be -4, and that would be included in the set, and that would go on to positive infinity. Now for number 4, they're asking us to put this in function notation. So here we see it. So we want to, in a sense, solve for the letter y. Well, this y would come over to this side as a -1y. So we would have then y, going from this end, is equal to a -4x squared minus 3x. And now we can substitute the y with the function notation. That's what they'll give you in the practice and certify, and that would be the answer. Now, this is in a 3-step problem. This is just the first step, and they're having some more down here, so we'll call that one number 5 too. But now, suppose our f of x is going to be f of 2. So that 2 is our value that we're going to put in there. What would that answer be? Well, remember we said there's input into the rule, and then you get output. This would be the x value going into the rule, and then your output is y. And that's what they want here. So we're going to say -4, parenthesis, substituting 2 for the x, that's going to be squared, minus 3 times 2. So there's the work to support. Now, 2 squared is 4, times a -4 is a -16, and then -3 times 2 is a -6. So the answer to this one would be a -22. And then this one is just using some of this the same way. Let's just say it was a -2 now. What would our answer be? Well, -4, and then the use of the parentheses is very important here, so you can watch the signs. And now what would you get? Well, the -2 squared is still 4, so this is still a -16. But then now -3 times -2 is a +6. So here we get a -10. All right. Now in example 6, they already have it in function notation. So what we are to do is put this value where the x is. So let's just do that. The square root of, and we can put that in parentheses to start with, x minus 1. That replaces this x plus 2 and a -5. Now, when we remove that parenthesis, this just becomes x minus 1 plus 2. So this is going to be x minus 1 under the radical, and then minus 5 out here. Now, suppose they said x is 5. Again, this is just a suppose. Well, this would be 5 minus 1 is 4. The square root of 4 is 2. 2 plus a -5, this would then result in a -3. But let's also use this to determine the qualified domain of this. Well, what values of x would make this 0? Well, again, we use that same technique. X minus 1 is greater or equal to 0. So we get X is greater or equal to 1. So in interval notation, it would start at 1 and go on to positive infinity. We did one like this, but this is just a little extra review. Remember, these are multi-part questions, and I'm only picking up on some of them. And this is example 7. And there's an equation in standard form. And if we convert it to the slope-intercept form, remember we could change that y I should say, to f of x. And again, these can kind of swing back and forth. But if you were to graph this, I've put it from standard form to slope-intercept. Our y-intercept is 1, right there. And our slope is 7/3. So I would go over 3. And then 1, 2, 3, 4, 5, 6, 7. It's off the graph. That would be where that other point is. Reviewing some of the things we've done in the past. But what is the domain of these? Well, we said that the domain of a line with positive slope, this is going to go eventually all of this way and all of this way, so it's all real numbers. And we show all real numbers as from negative infinity to positive infinity. Now for the range, again, it would be y values. This goes down to negative infinity and then eventually up to positive infinity. So this is also negative infinity to positive infinity, or in a sense, all real numbers, using that symbol for real numbers. Now, is this equation and this graph, does it represent a function? Does it pass the vertical line test? Again, as we pass this imaginary red line over the graph, it only intersects in one place. So yes, all positive slope graphs, linear graphs, are functions. And just to review, all negative slope graphs would be a function. Another review item. All horizontal lines would be a function. And the only one that is not a function would be the vertical line. I was making nice lines there. Let's make a nice vertical line. There you go. This, if that were a graph, the vertical line would superimpose on this. This would not be a function. All right, let's go on. Now for number 8, again, they're looking for the implied domain. Well, what value would make our denominator a 0 here? Well, if it were an 11, so x equals 11 makes this a 0. So our implied domain would be every real number, but not an 11. And how would you write that in interval notation? Well, from negative infinity up to 11 with a parenthesis. 11 is not included. The union symbol, and then 11 on the other side. Again, 11 still not included. And to positive infinity. So this one was pretty straightforward if you know the protocol. Now for number 9, which is what this one is, they want us to put it in function notation. So our y is there. We want to bring this square root of x to the other side. I'm going to put this one first here. X minus 3, the quantity squared, minus 4x, which is right there. And I'm going to just bring this here as a minus square root of x. And again, if you were going to put some value in there, whatever number it happens to be, let's say a 4, if x is a 4, and you're going to use the function symbol to replace the y, then this would be 4 minus 3 is 1. 1 squared is 1. Minus 4 times 1 is 4. Minus the square root of 4, which is 2. So again, this is multi-part. We're just giving you an example of what it might contain. This would be a negative 6 plus 1. This would end up being a 5 if our f of x were a 4. And now, how about the domain of this? Probably asking you that there. Well, because of the radical x, x cannot be a negative value, but it could be 0. So it's going to start with a bracket at 0 and then any positive number. Okay. Now, as we go on to our last example, this is the most challenging of all. And what I've included here as well is down at the bottom of your regular screen on practice, there'll be a tutor bar. So I've opened this up. Gives you kind of a flow chart of what's going on here. Now, they're asking you to take this function, and again, this is the rule here, and substitute these values. This is going to be our x value, where x is in this equation. So again, they're giving you the function here. Take a moment to copy it into your notes. And they're doing this in 2 steps. So we're going to take our x from here, and then this is our x, and we have a negative 2, and we're going to substitute the x plus a, which is squared. And again, our first part here, plus 3, and what is our x value? Well, x plus a, which is what we have here. So what are we going to put in this sort of intermediate step? Well, we're going to expand this, and let's do that in stages here. So this is going to be a negative 2. This will be x squared. Multiply these and double it, plus 2ax, plus square this, a squared. And this is going to be plus 3 times x plus a. Now let's clear parentheses here. So this is a negative 2x squared minus 4ax plus 2a squared plus 3x plus 3a. Now notice they're giving us this answer here, but that's only the first part. We've gotten this. We now have to subtract an x from this. That'll be our next step. Now I've shifted the screen so we could see it a little bit better. So it's negative x. So negative, there's my negative. And again, my x is x plus a. So removing these parentheses, this becomes a negative x here. I can just erase that. And this will become a negative a. Now we see if there are any like terms here. Remember, there's a 1 there and a 1 there. So it's 3x minus 1x. So this is going to become a plus 2x. And this is a 3a, and this is a negative 1a. So this becomes a plus 2a. And in a sense, everything else is the same. So negative 2x squared minus 4ax plus 2a squared is the final answer. Wow. Again, tedious, being careful of the signs and following what they're asking us to do. All right, this winds us up.